Good afternoon, everyone. Okay, so is the screen visible to all of you? Yes, just one of you confirm. Can you hear me?
Yes.
Yes, sir.
Yes, sir.
All right, all right. So let's start. See, in the previous class, I was taking this example and I discussed two methods. In one of the methods, I divided this thing by cos 11 degree. Okay. Then in one of the methods, I changed the whole question in terms of sine. And now I will change this whole question in terms of cos.
So your voice is cracking.
That may be because of the network issues. Just see if it is okay in some time, because okay, so sine 11 degree.
India's a democracy. The more we talk about it, the
Mute
more
yourself.
we instill this constant class when we cheat on a test. The teachers don't know.
See, I have to tell you every time in the starting of the class that mute yourself. See, I will be removing you from now onwards. You have to check yourself. Be responsible. So sine 11 degree. Sine 11 degree, this can be written as sine of 90 minus 79, and that comes out to be cos 79 degree. Using reduction formula, sine 11 degree can be changed to cos 79 degree. So in place of sine 11, I will write cos 79 degree. Answer we already know. Answer is tan 34 degree. This is the same question we were discussing in the previous class. So now I am solving this question by changing every term in terms of cos, and I'll be using two formulae. In the numerator I will use cos c minus cos d, and in the denominator I will use cos c plus cos d. So let's start with the numerator. 2 sine c plus d by 2 sine d minus c by 2. Remember the formula. Similarly, in the denominator, 2 cos c plus d by 2 cos c minus d by 2. Simplify this, we'll get the answer. So in the numerator, the first term will become sine 45 degree. Next term, this will be 34 degree. Similarly, in the denominator, simplify these brackets. This is 45 and next one will be 34. So if you put the values, if you put the values, you will get tan 34 degree only. Why? This will be get this will get cancelled. 1 by root 2 will get cancelled, and sine upon cos is 10. So tan 34 degree. So in this way we can proceed by any one method. Either I can change this whole question in terms of sine, or I can change this whole question in terms of cos, or I can change this whole question in terms of tan. If you remember the first method, in the first method I divided numerator and denominator by cos 11 degree, and then I changed it in the form 1 minus tan 11 degree upon 1 plus tan 11 degree. I changed in such type of form if you remember the previous class. And then using the example above it, There was a formula 1 minus tan theta upon 1 plus tan theta, and I said that it is equal to tan 45 minus theta. So from there also it came tan 34. So basically these are the three methods. Methods are not important, actually application of formula is important. We were discussing formula of tan in the previous class. I told you formula of tan a plus b, tan a minus b, tan 2a and tan 3a. Okay. But this question I was solving with the help of tan a minus b, and then I told you two more methods so that you can remember these two formula also. Alright, cos c minus cos d, cos c plus cos d, and in the second method sin c minus sin d and sin c plus sin d. So ultimately questions will come where you will have to use more than one formula. So learning the formulas is the first important thing. Then gradually it depends on the practice. So this was the example from the previous class. Now I am going to take another example. Okay, so next question. It is a proving type of question. We have to prove that tan 4x equals 4 tan x into 1 minus tan square upon this expression. See, whenever we have to prove a statement, especially in trigonometry, we have to prove that this is equal to that. We usually start with the side which is more expanded, right? So generally we start with the side which is more expanded, like the right hand side. 4 tan x into 1 minus tan square. We will try to simplify it and change it into tan 4x. But here we are going to do it the opposite way because that will be easy. It seems that simplifying the expanded form will be easy, but actually using formula in tan 4x, that will be much easier option. But the question is, if I start with left hand side, that is tan 4x, and you see that I have to change this function in such a big expression, that also I can see that everywhere there is tan x, right? Angle is x. Whenever there is tan, angle is x, but in the left hand side there is tan 4x. So can anyone tell me how we can move from or change this angle from 4x to x? What can be the steps? Can you relate
Tan,
it to any formula? Yes, please.
tan 2 into 2x.
Very good. So first of all, I will write 4x as 2 into 2x, and the reason behind is that I am going to use this formula that tan 2 is 2 tan a upon 1 minus tan square. So this is absolutely correct observation. So considering 4x as 2 into 2x, and now using this formula or comparing this form with this formula, I will write, consider this as a, alright. So 2 tan 2x upon 1 minus tan square 2x. So we are at the middle of the answer because see, from 4x we have reached tan 2x, and now I am going to use this formula once again, and that will give me the answer. Why? Because from 4x to 2x and then from 2x to x, so once again use this same formula for tan 2x. So what we can write in place of tan 2x? We can write 2 tan x upon 1 minus tan square x. Write this same formula in the denominator and note that square is there. So 2 tan x upon 1 minus tan square x. And square is there, so let us square it. Now nothing is left. It is just the basic calculation, taking LCM, cancelling if anything is coming common, and you will get the answer. So let's write all those steps. So in the numerator 2 into 2, that will become 4. You can see 4 tan x is here, right? 1 minus tan square. In the denominator you will take the LCM. Okay, let me square them first. So square of 2 tan x is 4 tan square, and here it will be 1 minus tan square whole square. So now we will take the LCM in the denominator. It will take few more steps. So if we take LCM here, see at this place, then 1 minus 10 square x whole square minus 4 10 square x upon 1 minus 10 square x whole square. Finally, the last step, 4 10x. This then, like, this is of the form a by b by c by d. So you know that we can write it as a into d upon b by c. So with 4 10x, I will write 1 minus 10 square x whole square, and in the denominator, it will be 1 minus 10 square x into 1 minus 10 square x whole square minus 4 10 square x. Okay, and that's the answer, because see, this factor will be cancelled one time. So in the numerator, we will get 4 10x into 1 minus 10 square x. This is exactly the same that we have to prove. See, what we want in the numerator? We want 4 10x into 1 minus 10 square x. Exactly same expression is there. And if you will expand the denominator, then you will get the same expression the denominator also. 1 minus 10 square whole square is 1 plus 10 to the power 4 minus 2ab will give you minus 2 10 square x, and we have minus 4 10 square x also. And that's it. Because see, if you will simplify this expression, in the denominator you will get 10 to the power 4 x minus 6 10 square x plus 1. So this is what you are supposed to prove. Though it may seem that the question is very lengthy, but it is actually not, because see, I could have written the answer by skipping these 2 3 steps, but then there might have been some confusion. So I'm writing each and everything in detail. Overall, the question can be summarized in 2 steps. That first of all, from 10 4x, I will change this question into 10 2x, and from 10 2x, I will change the question in terms of 10x. And for that, I will have to use this formula, that is 10 2a equals to 10 upon 1 minus 10 square a. So this is basically the method by which we can prove this. So if you will start with RHS, it will be very complicated. You will never reach this answer. If you want, you can try it on your
Excuse
own.
me, sir.
So left hand side will be a better option. Yes.
So could you please explain the third step?
This is step.
So the step after that, how you got 2 in the bracket 2 tan x upon 1 minus tan
Again,
square
I am
2x.
using formula. You did not notice that from 2x I have changed this angle to x. So how it is happening? I have not simply written it as 2 tan x. I have divided it also by something. Why? Because I am using this formula. So first of all, I am using it for tan 4x, and then I am using it for tan 2x. So from 4x you will reach 2x, and from 2x you will move to 10x. Why? 10 2x here. In place of a you put x. So 10 2x will be 2 10x upon 1 minus 10 square x. That is what I've used here.
Oh, okay, sir.
See, don't try to remember these steps. Try to remember the concept. From 4x to 2x, 2x, 2x. Okay. Because see, these things, these steps, no one can learn them. Whatever concept I have told you now, you practice this question after the class, or whenever you get the time, whenever you are revising. At that time, you use this thing and try to get the answer on your own. You are not supposed to learn these steps.
So,
Yes.
so we can expand by 3x plus x also now.
Very good
Instead
question.
of,
Yes. Correct. Let us do by that method only. Also. Method 2. LHS 10 4x. See, this is the way you have to think. It's not like that if I said 4x is 2 into 2x and 2x is 2 into x, and you said okay, fine. Try to visualize things. 4x can also be written as 3x plus x. That is absolutely correct. And now, after writing in this form, if I want to proceed by this method, then I will use formula of 10a plus b first, which is 10a plus 10b upon 1 minus 10a 10b. And see, I have to express the whole question in terms of 10x. So now I want to get rid of this term 10 3x. For that we have the formula. We have formula of 10 3 also. Let us use that formula. 10 3x is 3 10x minus 10 cube x upon 1 minus 3 10 square x. This is the formula of 10 3x. Then copy remaining term, that is 10x. In the denominator also, you use this formula 3 10x minus 10 cube x upon 1 minus 3 10 square x, and you multiply it by 10x. Now take the LCM and simplify. So when we will take LCM in the numerator, I will get 3 10x minus 10 cube x. Then I have to multiply this 10x by this 1 minus 3 10 square x. This is called taking LCM. So 10x will be multiplied by 1 plus 10x, and 10x will be multiplied by minus 3 10 square x. So it will become minus 3 10 cube x. Okay, then what you will have in the denominator? This thing 1 minus 3 10 square x. Then similarly here, the term which is in the denominator of this complete expression, we will take LCM here also. So with this 1, we are going to multiply the denominator 1 minus 3 10 square. So it will be 1 minus 3 10 square x. Then we have minus in between. It is 3 10x minus 10 cube x into 10x. And we have in the division again this term 1 minus 3 10 square x. See, this will be cancelled once again. Okay. Now what is left? Simplification. So if you observe the terms in the numerator, we have 3 10x plus 10x, that is 4 10x. Minus 10 cube minus 3 10 cube is minus 4 10 cube x. Denominator 1 minus 3 10 square. Then 10x multiplied by 3 10x into minus minus 3 10 square x. And minus into minus is plus. 10 cube into 10 is 10 to the power 4. Now from the numerator we can take 4 10x common. From the numerator we can take 4 10x common. Why we are doing it? We have to prove this. And in the denominator we have the same expression. Write it in the descending order of the powers. First 10 to the power 4. Then the middle two terms, their addition will be minus 6 10 square x plus 1. See, once again we have reached the same expression which is there in the right hand side. So in the previous class also we solved a question by three methods. Now here also two students suggested two different methods, but ultimately we are reaching the same result. So that is the way. This is the way to think, and only by improving your thought process or like practicing, then only you will be able to solve the questions in trigonometry. Because see, number of formula are too much. There is a lot of variation in the questions. There are different levels of question, level 1, level 2, level 3, all right. But it will not be happening so soon. Gradually you will be able to solve the questions, but learning the formula is important. And after observing the question, you should think that what formula I can use, how can I begin. So there should be some rough working in your mind before you start actually writing something with the pen. Okay, so it will take some time, maybe a week or so, but you will be able to solve the questions. But constant practice is important. See, this is the most important thing. You just can't learn the formula and solve all the questions in maths. That's not going to happen. Okay, so all right. So let me take one more question here. See these four formulae of 10. If we see in sine, there were like 9 formulae. In cos also there were like 9 formulae. In 10 we have only 4 formulae. But majority of the questions and important questions, they come from this section 10. Like there is another question of proving. Prove that 10 3x, 10 2x, 10x equals 10 3x minus 10 2x minus 10x. So again we have to prove that LHS equal to RHS. So 10 3x, 10 2x, 10x equals this. To prove this question, if you are getting anything, if you have any idea, you can let me know that we can start the question by using this.
So first
So using tan
10
3 and tan 2
3x.
formula.
Just a minute. Let her speak, then you please speak. Yes, you tell me what
So
you were saying.
first we will expand 10 3x into is equals to 10 2x plus x.
Okay, okay, right. Okay, yes. Now you can speak.
So yeah, same. When I was saying
Same.
the
So
same thing.
so you want to write tan 3x as tan 2x plus x, right? See one thing. Do not try to. There are two options. There are two options. But I generally don't. You know, I don't follow that process where what students do. They simplify left hand side to some steps, then they simplify right hand side to some steps, and then they will show LHS equal to RHS. That is usually not a good method. Either you proceed by LHS or you proceed by RHS, or or do not solve LHS and RHS simultaneously. Like then you show that you come in the middle of something and you say that LHS equal to RHS. You use different technique where you arrive at the result directly. What I want to say, let me explain. I'm not using LHS, RHS, anything. I'm just starting with the basic thing that 3x is 2x plus x. Okay. 3x is 2x plus x. Addition of 2x and x is 3x. Now, how to use it in this question? Listen carefully. If 3x equals 2x plus x, which is, therefore, their tangents will be equal. Full form of tan is tangent. Full form of cot is cotangent. Okay. So then their tangents will be equal. Now, in the left hand side, keep tan 3x as it is. Do not use the formula that tan 3 is 3 tan a minus tan cube a, something like that. Why? It is not required in the question. We want some terms in tan 3x also. Do not change it. What about right hand side? Do not write 2x plus x as 3x. That will not help us. Instead, read it as tan a plus b. Read it as tan a plus b and use the formula tan a plus tan b upon 1 minus tan a tan b. Write it like this using the formula tan a plus b. Okay. So now you can see
Excuse
that
me,
you have.
sir.
Yes.
So now tan 3x is the C. So you have written it as 2x plus x, but then there are many other ways in which you can write it, right?
Which term? Like, for
So
example,
like 3x can be written as 8x minus 5x, 4x minus
yeah, that's
1x.
fine. But are you observing these terms in the question? Is
No,
8x there
sir.
in the question that we have to prove? Is 5x there in the question? No, right?
Oh, okay.
So
So you have to
that
take
is
only
why I have.
relevant terms.
Yes, right, correct.
Okay, sir.
So that is why I have picked this combination. This is absolutely correct. See, 3x can be written as 10x minus 7x. 3x can be written as 8x minus 5. There can be infinite number of ways. But here I am selecting this combination. Why? Because these terms are present in the question. So we are strictly talking with respect to this question. That's why. So your question is absolutely correct. Now, in the right hand side, I have used 10a plus b. Now what is left? If you see that whatever we have to prove, there is no denominator on either side. Okay. So the natural step will be to shift the term on the right hand side to the LHS like this. And what's left here is 10 to x plus 10x. Now let's expand this and simplify. So 10 3x into 1 will be 10 3x. Then plus into minus will be minus. And we will have the product of these three tangents, that is 10 3x, 10 2x, 10x. Equals, on the right hand side we have those same terms, repeat, tan 2x plus 10x. In the next step you will get the answer. How? Whatever terms are present on the right hand side, you shift them on the LHS. So tan 2x is with positive sign, so it will be transposed here with negative. Similarly 10x, it will become minus 10x, and this term on the LHS, the product of these three tangents, shift this to the right hand side. Why we are doing so? Because that is what we have to prove. So what happened? I Neither I took LHS nor RHS. I started with the concept that 3x is 2x plus x, and in the process of taking tangent using the formula, I arrived at the result directly. So this is another way. Okay. This way also you can reach the question. It is not necessary that you always take LHS or RHS, but please do not solve some part of LHS, some part of RHS, then show in between. See, this is equal. This is not a good way to solve questions. All see this question, the previous one, they are there in NCRT also. Okay. especially those students who are going to give school exams or tests. These questions are important for them. Solve your school textbooks. Okay, whatever textbooks are there, at least solve their exercises. Solutions are available everywhere. And you can ask me also, no problem. So till here, these are all the formulae which may be asked in your school exams. Okay. Now I am going to give you some results. Do not use them in your school exams. And why we need them? Because we are also preparing for competition. So some extra formulae are also there. So specifically for competitive exams. So I'll be writing certain results. You add them, and I am clearly mentioning that you use them for objective questions only. All right. You can say that their results or formula is same. Cos a minus sin a whole square. This I think we have used, but I will tell you how it comes. 1 minus sin 2. Then next one is cos a plus sin a whole square is 1 plus sin 2. This is not square. In the right hand side it is 2a, twice of the angle. Cot a minus 10a, cot a minus 10a is twice of cot 2a, twice of cot 2a. And you note down right now, alright? Cot a plus 10a equals 2 cosec 2. I will prove some of them. Therefore, I will prove two of them because first and second are similar, third and fourth are similar. So I'll prove two questions. Okay, first one is very easy. You can even like prove it verbally. Can anyone tell how this result will come 1 minus sin 2a? Can anyone of you try? First one, you can
So
speak
a
up.
minus b the whole square identity.
Okay, fine. So when you will use a minus b whole square in the first result, what will happen? Can you tell me what will be the
So
expanded
you will
form?
get cos square a plus sin square a minus 2 sin a cos a.
Yes, correct. So
So
on
then cos
expanding,
square.
yeah, correct, correct. So on expanding, you will get cos square a plus sin square a minus 2 cos a sin a. Now by identity, cos square a plus sin square a will be 1. That is what I have written. And 2 cos a sin a. So this is formula of sin 2a if you remember. So we can prove it without writing anything. It's just simple proof that it will become 1 minus sin 2a. On a similar basis, second one will be 1 plus sin 2a. Now I am going to prove third result. I will start with LHS cot A minus 10A. I have to prove that it is equal to 2 cot 2A. Okay, so to prove this result, I will first change them in sin and cos. I will take the LCM. Cos square A minus sin square A upon sin A cos A. Now, can you recognize any formula at this step? Third one. Do you see any formula in
So
the third
cos
step?
square minus sin square is equal to 1.
Sure. Cos square A minus sin square is 1 or plus sin square is 1.
Oh, no, sir. What is it?
Yeah, still there is a formula, but anyways, no problem. Yes, anyone else? What is the formula here?
Cos 2a.
So cos
Yes,
2a.
correct. Numerator. See, cos 2a has four formulae. One is cos square a minus sin square a. First one is already used. That is only being used here. Then second is 1 minus 2 sin square a. Third is 2 cos square a minus 1. Fourth is 1 minus 10 square upon 1 plus 10 square. It's like that. So cos 2a. Why I used this formula? I have to change the question from a to 2a. So that is why I'm thinking about formula. Now can anyone tell me what is that next step by which we can reach the answer 2 cot 2a? Can anyone think of any step here?
Multiplying numerator and
So
denominator by
multiplying
2.
Very good. See, you will have to think like that, okay? Do not think that you will learn all the questions and you will do well. Think like this. I will give you such type of questions again and again where you have to apply. So multiply and divide by 2. Reason is obvious. See, either we can think that in the right hand side we have 2, right? This number 2. But till now we don't have any number like this. So we need to create it. So how we can do that? By multiplying and dividing. Also there is one more reason behind multiplying by 2, that in the denominator once again we will have this formula 2 sin a cos a sin 2a. So two things, because of the 2 which is present in the RHS, and also I want cot 2a. So I have only cos, sin is missing. So to create that we need to multiply and divide by 2. As a result, now you have the answer. Cos upon sin is cot. Cos theta upon sin theta is cot theta. Theta is 2a here. So it will become 2 cot 2a. That is RHS. Now on the similar basis, you can prove the fourth one. Change this cot a plus tan a in cos and sin, take LCM, you will get the answer. So these four important results, cos a minus sin a whole square, cos a plus sin a whole square, cot a minus tan a, and cot a plus tan a. Alright, these are the first four. Okay, now next three results, sin 60 minus theta, sin theta, sin 60 plus theta. Next one will be is in terms of cos and sorry cos theta, cos 60 plus theta, and last one will be in terms of tan 60 minus theta, tan theta, tan 60 plus theta. Okay, so fifth one the formula is 1 by 4 sin 3 theta. As I'm constantly repeating, please note down these formulae right now. 1 by 4 cos 3 theta, 1 by sorry here it is only tan 3 theta, last one tan 3 theta, no 1 by 4 because it will be cancelled when we will divide 5 and 6th result. I will prove one of them, that is fifth one. Okay, in the fifth one we have everything in terms of sign, so answer is coming in terms of sign only. So whatever proof I will be using in fifth one, similar will be in sixth. And if I divide the fifth result by the sixth one, I will get the seventh result. Why? Because sin x upon cos x is tan x. So sin 60 minus theta upon cos 60 minus theta will become tan 60 minus theta. Sin theta upon cos theta, tan theta. Sin 60 plus theta, cos 60 plus theta, tan 60 plus theta. So if you divide fifth equation by sixth, you will get the seventh result. That is why in fifth and sixth, 1 by 4 is coming, but in seventh, 1 by 4 is not coming because it has been cancelled. And sin upon cos is 10. So that is why tan 3 theta is there in the right hand side. I will take example also based on this. But before that, let me prove the fifth one. Sin 60 minus theta, sin theta, sin 60 plus theta. It is the product of these three sines. And I have to change it ultimately into 1 by 4 sine thrice of theta. So I am doing a bit of rearrangement, where I am bringing this term in between and I'm shifting sine theta here, which I can do because it is multiplication. So in multiplication, if you rearrange the terms, it won't make any change. But what is the reason behind it? Can you recognize any formula at this step? Any formula that you can relate it with second step?
So sine A plus B into sine A minus B.
Very good. This one, sine A plus B into sine A minus B, or sine A minus B into sine A plus B. See here, sine A minus B into sine A plus B is equal to sine square A minus sine square B. What is A here? A is 60, so it will become sine square 60. What is B? B is theta here, and it is into sine theta. Now, we are just two steps away. Sine 60 is root 3 by 2. This is the standard angle. Root 3 by 2 square is 3 by 4 minus sine square theta. When you will take the LCM, you will have to use formula of sine 3a. So let us take LCM. 3 minus 4 sine square theta by 4, and when you will multiply the sine theta with the bracket, you will get sine 3a, and that is what we have to prove. 3 sine a minus 4 sine cube a upon 4. What is there in the numerator? See this, sine 3 theta. Sine 3 theta upon 4. You have to remember these results. I'm saying again and again. If you won't learn them, you will never be able to identify them in the questions. So either there can be product of three sines, or product of three cos, or product of three tan. Another important thing is the angles. See, if there is any one angle which we assume as theta, then one of them should be 60 plus that angle, and one of them should be 60 minus that angle. Okay, in that way you will have to compare it in the question. Let us see let us see if we can find this in the coming question or not, if we can like compare it and see whether we can find this value. Here it is, sine 3 theta by 4. So let us start with a simple question. Find the value of sine 10 degree, sine 50 degree, sine 70 degree. See, next week we will have class on Tuesday, and it will be specifically practice class. I will not teach anything extra. No extra formula, just practice. So if anyone misses the class, it is not going to be any loss, all right? But you can watch the recording later on for those practice questions. But I will not teach anything, okay? But yeah, it doesn't mean it is extra class or you know time pass. No, I will solve some very good questions based on these formulae. So what is required from your side? You are supposed to learn the formula. I may even ask you in the next class, okay? So let's start with this question. Find the value of sine 10 degree, sine 50 degree, sine 70 degree. See, we have no knowledge of any of the values of the angles given here. Like sine 10 degree, we don't know its value. Sine 50 degree, we have no idea about its value. Sine 70 degree, no idea. Still, we can find the value of their product. Why? Using the fifth result. But for that, I told you that the question should be in this form: sine 60 minus theta, sine theta, sine 60 plus theta, and then it will give you the answer in a single trigonometric ratio, that is 1 by 4 sine 3 theta. Let us see if it is possible here. Yes, it is definitely possible, because if I write, if I assume that in place of theta I am putting 10, okay, so this is sine 10. What is this? This is sine of 60 minus. Please mute yourself.
Shut up.
These young students can study later. Then 70 is 60 plus 10. Okay, so sine 10, sine 60 minus 10, sine 60 plus 10. All right. It is exactly comparable to the formula sine theta, sine 60 minus theta, sine 60 plus theta. And what will be the answer? 1 by 4 sine 3a. Thrice of a. What is a? A is 10 degree here. I hope you are getting it. And the next step you will get the answer. 1 by 4 sine 30 degree. 1 by 4 into 1 by 2, that is 1 by 8. Okay, simple. But what is important is that you should be able to compare it with the formula. Let us take another example and I want you to try this question. Find the value of, all of you please try and tell me what is your answer. So the question is cos 20 degree, cos 40 degree, cos 60 degree, cos 80 degree. This is the question. If anyone gets the answer, let me know.
Sir,
Yes,
is it 1 by 16?
very good.
So yes, 1 by 16.
Good. So I was thinking that you gave 1 by 8, but you have given the correct answer. See, what we will do, we will keep 20, 40, 80 together. See, everything is in product only, so we can rearrange. And cos 60 we can write at the last. Why? Because we know its value. Its value is 1 by 2. So we just need to find the value of the product of these three. Cos 20, cos 40, cos 80. And how we are going to do it? Using this formula. See, this is cos 20 degree. Next one is 60 minus 20. And last one is 60 plus 20. And then into. Alright. Now use the formula cos theta, cos 60 minus theta, cos 60 plus theta. What is the formula? 1 by 4 cos thrice of the angle theta, which you have assumed as 20 here. Alright. Use proper brackets. Do not get confused. So 1 by 4 cos 3, cos 60 degree. This is also changing into standard angle. What is the value? Half. So this will become 1 by 16. This is the answer. Similarly, there can be question in 10 also. Okay. So that we'll see. So I told you 4 results there, then these 3. Okay. There is a table. Yeah. Again, there are 2 formulae and you can use them in school also. Okay. I forgot actually. There are 2 formulae in court also. So can be used in school also. See, whatever is being used strictly in school, that can be applied to competitive exam already. But there are some extra things that we study only for exams. Okay. So I'm clearly mentioning each and everything. Please do not complain later on, sir. My marks are cut, this and that. Actually, I forgot. They were supposed to be told after 10 a plus b and 10 a minus b only. So let us write the formula. First is cot a plus b. Cot a plus b is cot a cot b minus 1 upon cot a plus cot b. And next one is cot a minus b. And the formula is cot a cot b plus 1 by cot b minus cot a. Please note the second one. This is a little bit confusing because you know why I'm saying so? Because the order is reversed. In cot A plus B, it is cot A plus cot B. But in the second formula, it is not cot A minus cot B, it is cot B minus cot A. So it will change the whole answer. That is why I'm saying. Remember this one, second one. So they can be derived very easily. Let me prove it. Let me prove it. Because I did not prove any result of 10, I will prove the this one, cot A plus B. Cot A plus B is cot theta. What is cot theta? Cot theta is cos theta upon sin theta. Okay. Cot theta is cos by sin. And cos by sin, why I'm changing it in this form? Because I know their formula. Cos A plus B is cos A cos B minus sin A sin B. And in the denominator it is sin A cos B plus cos A sin B. See, I am telling you one thing. Please do not use this strategy to solve trigonometry questions that you keep modules beside your practice notebook. Okay. What many students do, they keep this page with them. All right. And they start solving question. Whenever they are having no idea, they will look at the formula again, solve the question, and they will do it constantly. Then what happens in the exams? We don't have such things. Then we are not able to solve trigonometry questions. So you please learn them first and then solve them. Okay. Or you are doing so much practice, then even if you are looking at the formula every time, you have solved so many questions that you have learned all the formula by default. Okay. That happens rarely, that people are solving so many questions in the starting of the chapter only. So that's why I'm suggesting you these things. Okay. So we have used formula of cos A plus B and sin A plus B. And when we look at this formula, everything is in terms of cot. And here we can see uh, terms in cos and sin and etc. So can any one of you tell me what should be that step which will change the second step to third step? That means the actual formula. What can I do here so that I get the answer cot A cot B minus 1 upon cot A plus cot B? What can be that step? How can I change this whole question in terms of cot in a single step?
So divide
Divide
both the sides
each
with
term by
sin A
Sir,
sin
sin.
divide
B.
by sin A sin.
Yes, your uh, your approach is correct, dividing sin A by sin B, but there is no both side. There is only one side. We are starting with LHS, right? So
Each
we have
term.
only LHS. So we should say that we have to divide numerator and denominator by sin A sin B. But you have observed it correctly that what exactly you have to do. So here the step is dividing numerator and denominator by sin A into sin B. Absolutely correct. See what will happen. Let us divide this first. Let us divide this term by sin A sin B. So cos A upon sin A is cot A. Cos B upon sin B is cot B. When I say divide numerator and denominator by sin A sin B, that means I will have to divide every term of numerator and denominator by sin A sin B. Basic rules of division. Minus. I have to divide this also by sin A sin B. What will happen? 1 will come. Then denominator. In the denominator, first term is sin A cos B. We are dividing it by sin A sin B. So sin A will get cancelled and cos B upon sin B will become cot B. Similarly, the last term will become cot A. Now in addition, if I write 2 plus 3 or 3 plus 2, it is same. So if I write cot B plus cot A or cot A plus cot B, it won't make any change. So ultimately it is same. But same is not true for subtraction. 2 minus 3, 3 minus 2, they are different. So that is why I am saying for second one you remember that it is cot B minus cot A only. Okay. And the same way you can prove this question. Okay, just do one thing. Find this value. Find the value of cot 15 degree. Do this. Value of cot 15 degree. Find this.
Two plus root three.
Yes, correct. Good. So cot 15 degree. Okay, we are solving these questions, right? We have calculated so many values: sine 15 degree, cos 15 degree, etc. So here, cot 15 degree, you should know what is the concept. We split the angle into two parts such that we know their values. So now I split it in 45 minus 30. As a result, I will use formula of cot A minus B. That is cot A cot B plus 1 by cot B minus cot A, if you remember. That is what I was discussing. Now let us put these values. Cot 45 is 1. Cot 30 is root 3. Because tan 30 is 1 by root 3. So cot is reciprocal. So this comes out to be root 3 plus 1 by root 3 minus 1. This is absolutely correct. But if you give the answer in simplest form, that is better. And that means we have to rationalize. Okay, so this comes out to be root 3 plus 1 whole square. And in the denominator it is a minus b, a plus b. So that is 3 minus 1. So we'll square this. A plus b whole square will get 4 plus 2 root 3 here. And it will be 2. Finally answer will be 2 plus root 3. That is cot 15 degree. So we have done it so many times, like in sine 15, cos 15. Just formula is different, concept is same. Okay, splitting of the angle in two, so that we can use formula of a minus b. It could be sine a minus b, cos a minus b, tan a minus b, cot a minus b, like that. So on the basis of this, there are some important trigonometric values, some extra trigonometric values that you need to remember. Okay, extra angles, the ones that you have studied now in class 11th. Some important values. You are supposed to learn them for objective questions. Some important values. So 15 degree, then, and not all the values. I will tell you what are the important ones or the necessary. For 15 degree, we need to learn values of sine. Four ratios are important: sine, cos, tan, cot. Okay, sine, cos, tan, cot. And I will draw this table like this. Okay. See, if I want to write the value of sine 15 degree, I will read this sine, and then from column I will read 15, and value I will write here root 3 minus 1 by 2 root 2. We have already calculated this value. Okay, sine 15 in the first class itself, sine a minus b, like that. Cos 15. Now we are supposed to learn the values. Tan 15, 2 minus root 3. It came from root 3 minus 1 upon root 3 plus 1. Cot 15, 2 plus root 3. Just now, proved just now. Then 1836. Oh, wait a minute. 22 and half. We have derived one value that will be used. Then 36. All right. Not required. Wherever I am putting this dash, that means these values are not required to be learned. 10, 22 and half. We have proved this value in the previous classes. I think previous class only. 10, 22 and half. 10 pi by 8. Root 2 minus 1. And cot is reciprocal of it. So you will get this value as root 2 plus 1. Now tan 18, cot 18 not required, not required. Sine 18 degree. We have not solved it till now. We will prove it. How it comes. Sine 18 is root 5 minus 1 upon 4. Little bit difficult to learn. These values 18 and 30, but they may take some time, but sooner or later you will learn them. Sine 18, then cos 18. Wait a minute. Sine 36. Yes. Sine 36. Under root of 10 minus 2 root 5 by 4. Then cos 36. Sine 54. Under root of 10 plus 2 root 5 by 4. And finally cos 18. Just a minute. This value is wrong. Cos 36 is sine 54. So this is root 5 plus 1 by 4. And cos 18 sine 72. So this is 10 plus 2 root 5 by 4. Okay. This is the table. So we have already, and wherever there is dash, that means these values are not required to be learned. Okay. 15 degree, we have proved every value. Sine 15, we learned to calculate how sine 45 minus 30, use formula of sine a minus b, like that. Cos 10 cot, we have derived every value. 10, 22 and half degree, previous class we proved it. Cot 22, reciprocal of it. Cot 22 and half, reciprocal of 10, 22 and half. So 1 upon root 2 minus 1. Simplify it, rationalize it, you will get root 2 plus 1. Then these values are addition now, 18 and 36. So I am going to prove one of them. That will give you an idea how we calculate values of 18 and 36. See, all the values are positive y because these are angles of the first quadrant. Okay. So this one sine 18 root 5 minus 1 by 4. See, no one is going to ask how it came. So I could have just simply made this table and asked you to learn by the next class. But you should have an understanding why how things are coming. So try to understand this one. Little bit difficult, but I hope you will get it. Sine 18 root 5 minus 1 by 4. And similarly, other values can be proved, but we will not be actually proving everyone. Remaining you have to learn. So let us start. Okay, one more thing. One more thing. If we consider the table of 18, so the multiples will be 18, 36, 54, 72. Okay, 54 and 72. I have not written the values because they will change in these values only. What I want to say, like, see, in fact, I'm asking you this question. Can anyone tell me? Can anyone tell me what is the value of sine 54 degree from the table? Can any one of you tell me? While looking at this table, what do you think? What is the value of sine 54 degree?
Root 5 plus 1 by 4.
Yeah, that's correct. See, now you must be wondering 54 degrees nowhere written. How we are asking this question? Because you are class 11 student and you know trigonometry. That there is something called reduction formula. Sine 54 is sine of 90 minus 36, and this will ultimately change to cos 36. And do we have the value of cos 36? Yes, here, root 5 plus 1 by 4. So that is what I am saying. So 54 and 72 I have not written here, but please remember they can be calculated from 18 and 36 using reduction formula. So just like cos 72 degree, if someone asks this value, then using reduction formula you can change it into sine of 18 degree, and we have this value as root 5 minus 1 by 4. Remember this thing, all right? 54, 72 can also be there in the question. Okay, so I was saying that we will prove this value that sine 18 degrees root 5 minus 1 by 4. All right. Let us see how this comes. Pay attention to each and every step. Okay. We will miss a single step, then no, will not be able to understand. I have to find sine of 18 degree. Let's start by saying that theta is 18 in this question. Okay. So if theta is 18, what is 5 times of theta? 5 times of theta is 90 degree. Okay, that is okay. Now 5 theta can be written as 3 theta plus 2 theta. Till you come to see how these values are derived. Starting with this simple thing that theta is 18 degree, you will see where the question is going. So 5 theta is 3 theta plus 2 theta, that is 90, and 3 theta becomes 90 minus 2 theta, right? 90 minus 2 theta. Finally, just yeah, let us take sine both sides. No, wait a minute. Let us take cos both sides. Cos. You'll know the reason why I'm taking cos. I'm supposed to find sine 18. Why we are taking cos? We'll come to know. So taking cos both sides. Apply the formula. What is cos 3a? 4 cos cube a minus 3 cos a. At each step, remember this thing that theta is 18. Okay, keep this in mind because that is what we are supposed to find, sine 18. So cos 3 is 4 cos cube a minus 3 cos a. In the right hand side, use reduction formula cos 90 minus x sin x. So sine 2 theta. Use formula of sine 2 theta in the next step. Sine 2 theta or sine 2a. That is what? 2 sine a cos a. Now I will cancel cos theta from both sides. Usually I say we do not use these things. We do not cancel terms from both sides. But you know why I'm doing so? Because cos theta is non-zero value. We can only cancel non-zero factors from both sides. See, this is a very basic concept in mathematics. Still we make mistakes. What I'm saying? We can only cancel non-zero terms from both sides. So what I did, I take cos common from left hand side. I took cos from 2 sine cos and I cancelled it from both sides. Why? Because cos theta is not zero in this question. Can you tell me why? Can anyone tell me?
Theta is 18.
Very good. That's it. See, theta is 18 degree and cos 18 is not zero. In fact, if you remember, cos 90 is zero. All right. So theta is 18 in this question. So that is why cos 18 is a non-zero value. So we can cancel from both sides. Now, as I am saying again and again, we have to find value of sine of 18. So let me change the question in terms of sine theta. So this is 4 minus 4 sine square. Now after completion of this proof, do not ask me, sir, do we have to learn this? No, for your understanding. 4 sine square plus 2 sine theta and minus 1. I have shifted and written it in the form of quadratic. Just like we use quadratic formula for x, let us use quadratic formula for sine theta. Or consider that x is there. 4x square plus 2x minus 1 like that. Use quadratic formula minus b plus minus b square minus 4ac by 2a. A is 4, so 2a will be 8. Sine theta is minus 1 plus minus root 20. Root 20 can be written as 2 root 5. Root 20 is 2 root 5. Finally, I can take 2 common and cancel it. And I have a last question for you. Now let us come back to the first step. What is first step? Theta is 18. Theta is 18. Therefore, sine 18. We are getting two values. One is minus 1 plus root 5 by 4, which is our answer. If you remember the table, root 5 minus 1 by 4. And second one is not there in the answer. Why it has been rejected? Can anyone tell me?
First quadrant. First quadrant.
Very good. That's like it. Now you are giving answers. So ASTC rule, sine 18 degrees positive. Okay, sine 18 degrees positive. And this is a negative value, so this will be rejected. And we are left with only one answer, that is root 5 minus 1 by 4. So it is completely different from all the type of values that we have been deriving till now. Sine 15 degree, it was very easy. 45 minus 30, 10, 22 and a half, that also we solved. Okay. Other angles we are calculating 120 degree, reduction formula 135. This is totally different. 18 and 36. Okay, their working is something like this. If you remember it, it's fine. If you understand, it's okay. If you don't, just remember the value. All right. But I don't think that any one of you is not capable of understanding these things. Okay. With time, our thought process improves, and gradually, if we are working on the chapter, then definitely these will be very easy for you. So these are the values. I have calculated sine 18. Similarly, other values can be proved but not required for now. Now you are supposed to learn these values. See, if do you think you have that much time in exam that you find the value of sine 18 degree by this method, like doing all this and then you will say, oh, sine 18 is this much, let me use it? No, remember these values. Okay, because of the time constraint, that is the reason. All right, now, so enough of your roasting of your brain. Okay, so many formulae I have given you today itself. I think that will be it. Now from your side, I'm leaving you early. Okay, but don't be very happy because of this. But in the next class, when you will come in the next class, I can ask formula from anyone by his or her name. I can ask any one of you by your name and ask me, and I can ask you tell me the formula of sin a minus b or cos a plus b. At that time, you are not supposed to mute yourself. You won't say network is not coming. All right. Please come prepared, and I hope all of you will be able to tell me all the formulas. I think you will be doing this thing. All
So,
right.
so please scroll down.
Yeah, sure. And
Scroll to
the
the
students who have this maths test on 5th, best of luck. All right. And if you have any doubt, still I'm saying you can ask me. Okay. And the next class, it will be a practice session, formula hearing session. Okay. So come prepared. You also have test other people. Rest, the class is over. Thank you for today.
Excuse me, sir.
Thank you, sir.
Yeah, just wait a minute.
Thank you, sir.
Yeah, please. What is your doubt?
So we have test on case.
No, some of the students actually, some of the students have tests in their schools. I'm talking about that
Okay, sir.
test.
Sorry, sir.
Yeah.
Sorry, sir. Thank you, sir.
All right. Bye, everyone.
Thank you, sir. So why there are no values for sine 22 and a half?
No, if you want, I can even write those values, but see, they are not important. They are not asked in the questions. That is why. But if you want, we can derive values of sine 22 and half also. But they will be treated as question, not a part of formula or learning. Okay. In the next class, we will try
Okay,
to
sir.
solve, get some of these values which we have not written here, right?
Okay, sir. Thank you,
Like
sir.
for example, listen, tan 18
Yes.
degree. You must be asking, sir, why tan 18 is not written? See, tan 18 is not something that you don't know. Divide sine 18 by cos 18. What happens? What is tan theta? Sine theta upon cos theta. So sine 18 upon cos 18, you have both the values in the second column. You divide it. What will be tan 18? Root 5 minus 1 upon root of 10 plus 2 root 5. But you know it is difficult to learn. So remember sine and cos. You divide, you will get 10. What is the problem? Okay.
Okay, sir. Thank you, sir.
All right. All right.
Thank you, sir.
Okay. Bye.